Hey everyone, this video is over evaluating piecewise functions. So first off, starting off with what is a piecewise function. A piecewise function is made up of two or more functions. The domains of the functions are restricted so they do not overlap. Okay, we will get into graphing, but I wanted to start by evaluating first. So some steps that might help us with evaluating is to first determine which part of the function includes the value. So that's looking at the domain restriction. And then you plug that value into the expression and solve it. So if we look at our first example, it says evaluate the piecewise function below. So notice we have g of x, and it has two different functions that have different domain restrictions. So it is x squared plus 2x plus 1 if x is less than -2. And then it is 1 minus x squared if x is greater than -2. So let's go ahead and evaluate. So our first one we have is g of -3. What this says is when x is -3, what is the y value? So it's asking when x is -3, what is the y value? So you have to determine which one it falls in, and it's going to fall in the purple highlighted function, that top function, because -3 is less than or equal to -2. So we evaluate by plugging in -3 for all the x's. So I have -3 squared plus 2 times -3 plus 1. That would be -3 squared, which is 9, minus 6 plus 1. That would give us 9 minus 6, which is 3, plus 1, which is equal to 4. So g of -3 is equal to 4. Looking at B, it says g of -2. G of -2. So that would be when x equals -2. Well, x equals -2 right here because of that or equal to, which means we're using that top equation again. So I'm going to plug in -2 squared plus 2 times -2 plus 1. That would be 4 minus 4 plus 1, which just equals 1. So g of -2 equals 1. Looking at g of 0, so we're trying to figure out where 0 would fall in. That would fall in on that second equation. 0 is greater than -2. So that means we're going to use that top equation, or that bottom equation, and do 1 minus x squared, but instead of x squared, we're going to plug in 0. So 1 minus 0 squared is just 1 minus 0, which is just 1. Looking at the last question we have g of 2. G of 2 is asking when x equals 2, what is the y value? So again, that falls on that bottom equation. So I have 1 minus 2 squared, which is the same thing as 1 minus 4, which equals -3. So g of 2 equals -3. Moving on to example number 2, evaluate the piecewise function. So we have a new piecewise function with some problems. So go ahead and pause the video and try them out and then check your answers. So again, we have 3 piecewise functions. We have our top function, x times x squared plus 1, if x is less than or equal to -2. We have 4 plus 5 if x is greater than -2 but less than +1. And lastly, we have 1 over 2x minus 3 if x is greater than or equal to 1. So first we have h of -3. H of -3 says that my x is going to be -3. When my x is -3, that falls into this top equation right here. So I'm going to plug in -3 for each x. So I have -3 times -3 squared. Make sure that -3 goes in parentheses when you square it, plus 1. So that would be negative 3 times 9 plus 1, which is 10. And negative 3 times 10 is negative 30. So h of negative 3 is negative 30. Moving on to B, h of negative 2. So again, we use that top one because it has the or equal to attached to it, and we don't use that middle one. So we have negative 2 times negative 2, making sure we put it in parentheses, plus 1. That would be negative 2 times 4. Negative 2 squared is 4 plus 1, which is 5, which gives us negative 10. So h of negative 2 is negative 10. Looking at our next one, we have h of negative 8. H of negative 8. That also falls in the first one because our x equals negative 8, and negative 8 is less than negative 2. So I have negative 8 times negative 8 squared plus 1. That would be negative 8 times negative 8 squared is 64. 64 plus 1 is 65. And negative 8 times 65 is negative 520. So h of negative 8 is negative 520. Looking at D, it says h of 0. H of 0 falls in this middle one right here. So I'm going to plug in 0 for x because h of 0 means my x equals 0. So I have 4 times 0 plus 5, which is 0 plus 5, which just equals 5. So h of 0 equals 5. Looking at E, E says h of 1. So that's asking me when my x equals 1. My x equals 1 on the bottom equation, the purple one, highlighted in purple. So because it has that or equal to attached to it. So I have 1 over 2 times 1 minus 3. That would be 1 over 2 minus 3, which is equal to 1 over negative 1. So h of 1 is negative 1. Okay, if we do h of negative 1, that falls into this middle equation. So I have 4 times, let's see, 4 times negative 1. There we go, sorry. My x equals negative 1. 4 times negative 1 plus 5, which would be negative 4 plus 5, which equals 1. So h of negative 1 is 1. Looking at example 3, evaluate the piecewise function f below. So same concept, except this time we're using a graph. So f of negative 3, you find negative 3 as an x value on the graph, so negative 3. Notice that it has this point and this point. You do the one with a closed circle. That is the one that's going to be the answer. So that would be this point right here, which would be 1. F of 1, again, I have an open circle and a closed circle. We go with the one that is a closed circle. So that would be 6. F of negative 5, so I find negative 5 on my x-axis. I find where the graph hits, and that y value would be negative 3. F of 3, we find 3 on the x-axis. You find the point that corresponds with it. That would be negative 4. F of 7, so f of 7 would be right here on the graph, and that y value is 0. And lastly, we have f of -1. So I go over -1 on the x-axis. I find the graph where it hits. That would be at 6. So if you have any questions over any of the evaluating of piecewise functions, please write down your questions and make sure you ask your teacher for help when you see them. And I will see you in the next video.